Welcome to this explainer. Today, we're diving into exactly what it takes to architect the next generation PACS. We're talking about transforming your picture archiving and communication system from what's essentially a dusty digital filing cabinet into a unified, highly advanced intelligence layer. I mean, if you're involved in health IT or radiology administration, you already know the deal. The demands on our imaging infrastructure have completely outgrown the systems of the past. Trying to run a modern diagnostic center on legacy infrastructure? It's literally like trying to stream 4K video on a 90s dial-up connection. It just doesn't work. So today, we're going to break down the technical realities of what a 2026 platform absolutely must look like.
Think of this explainer as a literal construction blueprint. Here's our agenda. We'll quickly cover the end of legacy PACS, building the cloud foundation, interface and context sync, wiring the intelligence layer, standardizing AI workflows, and finally, securing the 2026 platform. Let's get right into it.
Section 1. The end of legacy PACS. Let's start with the foundation. And honestly, why those legacy systems we've relied on for decades are simply no longer viable for modern diagnostic centers. Okay, so let's dive into the core issue here. We're currently dealing with a staggering 30 to 50% spike in study volumes. And here's the real kicker. This is happening without any proportional growth in staff. Radiologist burnout is a massive, critical issue right now, and we're facing a crisis that basic storage architecture simply cannot fix. If your software isn't actively working as a co-pilot to help manage this massive load, it's just holding you back.
It's a night and day difference between the old paradigm and the new reality. Legacy PACS? Well, it was basically an isolated storage repository. It was siloed, locked behind heavy VPNs, and notorious for forcing you into duplicate data entry. But the 2026 standard is a completely unified clinical imaging platform. It's a cloud-native, operational backbone that acts as the true intelligence layer of radiology. We're talking about using automated orchestration to intelligently route cases to the exact right specialist based on their credentialing and availability. That's a huge shift.
Section 2. Building the cloud foundation. To actually build this intelligence layer, you have to lay down a robust, highly scalable cloud infrastructure first. You just can't build a 2026 platform on 1990s server architecture.
So, when you're building your platform, this is your materials list. To handle incredibly high spatial resolution DICOM formats and massive traffic, you need serious modern tools. Things like Kubernetes and Ceph, which distribute loads and redundant storage seamlessly across multiple nodes, giving you incredible elasticity. Under the hood, using a memory-safe language like Rust, alongside Red Panda for asynchronous message queuing, lets you handle DICOM CStore SCP services and metadata extraction without even breaking a sweat. Toss in Postgres as your primary index for patient and study metadata, and Apache Doris for logging, and boom, you've got a powerhouse system designed for global scale.
Section 3. Interface and context sync. Next up, we need to frame the interface. It is absolutely crucial that we move away from those heavy, localized installations to a streamlined, highly accessible workflow. Look, radiologists today are working from hospital reading rooms, home offices, satellite clinics, you name it. Because of that, you desperately need a zero-footprint web viewer like the open-source OHIF viewer. It retrieves metadata ahead of time and streams pixel data instantly. By tapping into modern web technologies like React and Cornerstone 3D, radiologists get full diagnostic fidelity directly in their browser. No heavy installations, no massive VPN headaches, just seamless access.
But here is where the true magic happens. A radiologist is usually working across a reporting system, a PACS, and a dictation system all at the exact same time. To get a true single-pane workflow, you integrate FHRcast. Modeled after the WebSub protocol, FHRcast is basically the glue. It synchronizes context across all your different clinical applications in real time. So when you open a patient's chart in your reporting system, your dictation app instantly knows to switch to that exact same patient. It's a total game changer. Section 4. Wiring the intelligence layer. Now let's wire up the most critical and complex part of our 2026 blueprint. This is where AI makes the jump from being just a separate standalone tool to a fully integrated part of the diagnostic process. We orchestrate this using an evidence-to-report architecture. In this setup, the AI orchestration sits squarely between the imaging data and the structured reporting workspace, because AI needs to be a structured, evidence-linked layer that connects measurements, prior reports, and segmentations. It shouldn't just be an autonomous text generator that spits on a final report, right? It's all about preserving human review while intelligently linking findings, like, say, a 7mm pulmonary nodule.
directly to the underlying image evidence and the patient's longitudinal history. Section 5, standardizing AI workflows. To ensure this AI orchestration actually plays nice across different vendor algorithms and hospital systems, your architecture has to rely on strict interoperability standards. This requires a rigorously mapped, standardized ecosystem. Interoperability isn't just a fancy IT feature anymore. It's a hard clinical requirement. You deliberately assign DICOM to imaging native data, using DICOM segmentation for lesion masks and DICOM structured reporting for quantitative measurements. And for enterprise clinical data exchange, you use HL7 FIR to share the finalized diagnostic report straight to the EMR. And of course, the whole shebang is grounded in standardized terminology like RADLEX and SNOMED CT. Standardizing your workflows with the IHE AI workflow profile allows you to treat AI models as managed tasks. By using RESTful DICOM UPSRS transactions, your task manager can seamlessly request, manage, and monitor these AI inference tasks. Whether your AI model is hosted up in the cloud or running locally on-prem, this standardized pull or push workflow ensures that the results, like a flagged abnormality or a generated markup, flow securely back into the image manager and instantly update the radiologist work list. Section 6, securing the 2026 platform. Finally, we have to fortify this entire structure because as we connect cloud environments, AI models, and web viewers, we drastically expand our attack surface against the highly sophisticated cyber threats of 2026. Traditional perimeter defenses, like just throwing up a firewall, yeah, those are entirely insufficient for modern imaging workflows. Your platform must be locked down with zero trust principles, where literally every request is verified and strict network segmentation is enforced. Plus, when you're training or utilizing AI, you need privacy-preserving frameworks. We're talking about federated learning, which trains models across decentralized datasets without ever moving the raw images, and homomorphic encryption, which actually allows computations directly on encrypted data. You also have to implement continuous vendor risk management, because a compromised third-party maintenance account can easily become a backdoor right into your hospital network. This next part is incredibly sobering, but it highlights a massive looming threat. There's a harvest now, decrypt later strategy out there right now. This means attackers are literally stealing encrypted medical data today, just sitting on it, waiting for quantum computing to become powerful enough to break our current cryptographic systems. This is exactly why medical imaging providers must begin implementing quantum-resilient, hybrid cryptographic schemes right now. If you're building a long-term patient archive for 2026, post-quantum encryption isn't some science fiction concept anymore. It's a mandatory requirement to protect patient confidentiality for the decades ahead. So, as you look at your own infrastructure blueprint and the technology stack your diagnostic center relies on, you have to ask yourself a hard question. Are you building the intelligence layer of the future? One that actively assists radiologists, seamlessly integrates AI, and secures data against tomorrow's threats? Or are you just accumulating legacy debt by building a slightly faster filing cabinet? The technology is here right now. The choice of how to build is completely yours. Thanks for joining me on this explainer. Keep questioning your infrastructure and keep learning.